So for the second question, we're being given a function. This is the first question, by the way. Yeah, the first question of test one for the second test. So we're being given a function. We're being told to find if it converges or diverges. So now I want to give you a brief background. Although I've done a full video about it, I'll give you a brief background of convergent and divergent functions. So let's say I'm given a function. This is your y, this is your x. So now you have maybe this function. Let's label this g of x, and then you're given another function. The other function is, it's not touching the x-axis, by the way. It's going somewhere here. So the other function is f of x. So now when you find an integral, well, it's just the area under the curve. So now let's say you have the limits. Let's say you want to find the integral of infinity to 0 of, let's say, g of x. I think let me use red. G of x, right? There's a certain comparison test that is used. So it says, I'll write it down. When a bigger, let me just say it, when a bigger function converges, the smaller one converges as well. So now if g of x converges, then we know that f of x definitely converges. And then when f of x diverges, then we know that g of x also diverges. So it works one way, it doesn't work both ways, by the way. It's just one way. So if the smaller function diverges, we know the bigger function diverges too. But then if the smaller function converges, you don't know what happens to the bigger function. Another way to think of it is think of converging as surrendering, and then think of these two guys as maybe an army, right? So now if a bigger army can surrender, which is converging, which means the smaller function can also surrender. And then if the smaller army, and then if a smaller army can diverge, which is not surrendering, then it means the bigger function can not surrender as well. It can fight the battle. So if you think of that in those lines, I think it will be quite easier to find out. So now we're going to do a comparison test. We're going to say we're going to get this one. So wt plus 1 over w squared w squared w to the power 3, by the way, cosine to the power 3 w, this is cosine, plus 1. Well, for all values of x is greater than 1, this function would definitely be greater than w to the power 2 over w to the power 3 cosine to the power 3 w plus t. Now this is because whenever you add the 1, you increase the denominator, the function is going to be big. So definitely this function, it's bigger than this one. And then from here you can go on and cancel the w's. We have got 2 w's there, we've got 3 w's there. So we're going to have 1 over w cosine to the power 3 w plus 1. So now all we have to do is check if this one is converging or diverging, and then we know that definitely in here we are always going to get a positive value that will not actually affect t a lot or change it into a negative or something. So now here we are going to do the comparison test. We are going to say 1 over w, the integral. We are being given the integral to the upper bound infinity and the lower bound 6, and this one is dw. So now by the p-test, you can say is by the p-test where p is equal to 1, we can conclude that the integral, that we can write this integral is divergent, where p is equal to 1. And so we know that when p, by the p test, if you viewed it, if you've gone through, you're going to realize that by the p test, p in this situation is less than 1, which means that this is divergent. And thus you can conclude, after writing all this, you can conclude to say this one, you can say therefore this one is divergent as well. So that's all for question 1.